I'm
Yes, we can.
assuming so. All right, I'm assuming so. Thank you. All right. Hey, welcome everybody today. This is Greg Ansager, um, based in Cincinnati, Ohio. I'm with HashiCorp and I lead the worldwide cloud strategy, and simply delighted to welcome everybody today to spend a few minutes with us. What we're going to really cover today is something that's really important to our customers, both AWS and HashiCorp, is what are the key considerations for getting HashiCorp Terraform into production? Really the build versus buy discussion. And we're really aligning it with Amazon on companies that are either beginning or on their cloud journey with AWS. I'll be your moderator today. But before we begin, a couple of housekeeping items just to kick us off. This session will be recorded and we will share it post-event. If you have any questions throughout the presentation, please place those questions into the chat window in Zoom, and we will do our best to address any of the questions that are proposed. And towards the end of the session today, we'll send a survey link in the chat to complete. By completing that, you'll automatically register to win a wonderful and cherished HashiCorp t-shirt. So please stay on and complete the survey so we can notify the winner. So with that, let's get started. I want to first introduce a dear colleague from AWS, Welly Xiao. And Welly, please take it away.
Thank you, Greg. Let me share my screen. I hope everybody can see the screen. And I'll turn my video for just a second here, just to say hello to the participants. Thanks again for coming today and investing your time. Really appreciate it. I will stop my video just to perceive the bandwidth. So my name is Welly Xiao. I'm the partner solution architect from AWS. I'm here based in Houston, Texas. Just very quickly about me, I come from on-prem infrastructure background, started to play around with AWS. It was like easy to classic at the time with public IP. It sounds kind of funny to me at the time. So I waited for years until like VPC and EBS came in. And then since then, I've been doing a lot of like design integrations, mostly with the partners. And that's also how I get introduced to infrastructure as code. I play with Terraform since like 2016 and built a couple of private modules and kind of use it on my projects. I'm also part of the technical field community in AWS in the management and governance with focus on the control services. And today I want to start the talk with an overview of cloud computing with AWS, why customer trust us to run the workload, and how customer can scale their cloud adoptions with AWS. So with that, let's get started. In the fullness of time, we believe every company will use cloud in the future. But why this company choose AWS? It's very obvious maybe for some of you in here, but let's kind of get through that journey in motion itself. First thing is about agility. The idea that you can spin up resource as needed, you can deploy from 1 to 100, even 1,000 of server in minutes, and you can quickly deploy and roll out the new applications. You can do experiment very frequently, and then you can do that quickly. And then when the experiment doesn't work, you can deprovision that, and then there's no risks. Coming from my previous backgrounds, like I used to purchase hardware and then they have 6 month lead time and then you use it, right? There is nothing about like, well, the project doesn't work, then what we gonna do with with this hardware? That idea is suddenly gone with this agility that you have in the cloud. And with that agility as well, it comes with the cost savings. You trade that capital expense into a variable expense and you pay as you go. And then the scale of the economy in AWS also means like we can purchase millions of hardware, thousands of servers, and etc. And then we can kind of bring that variable expense and then lower it to you by this scale of the economy. I mentioned about how quickly you can do and spawn up a new resources, but then it's also come with this idea of elasticity. So I used to provision and buy hardware and kind of do a modeling of what's that's going to look like in 3 years. So my first and second years of the hardware running, sitting in the data centers with 10% CPU usage and maybe even less. And you kind of try to figure out, well, is it normal? What is that? What is that demand will looks like in the future? But with the API-driven models in AWS, you can scale up and down. You can do horizontal, vertical scaling. You can drive that through infrastructure as code, automations, and you can quickly react to that demand. You can imagine, for example, where we do things such as the like a Black Friday, for example, where millions of customers come and then do a shopping in AWS. And with elasticity, agility, there's also come another benefit. You can innovate much, much faster. You can focus your highly available IT team and resources into developing applications that differentiate you with competitors and transform your customer experience. It's coming back from me. My own experience, I grew up and then do IT, breaking up server, installing application, OS, and etc. And then I start learning about what is that fully baked machine image can be launched through a Terraform, for example. How do I use a Lambda function to maybe achieve even the same result? So that learning experiences keep coming back to me, and then it makes me able to innovate much, much faster. And AWS, we have 25 regions, 81 availability zones, and then with that, you have this extended reach out to any market that you want to target. So I like to always come back to this quote in here from Andy Jassy. There is no compression algorithm for experience, and this is really a reflections of years of AWS on experience running and serving our customer needs. Our customers trust AWS to run the workload, not just because how many years we have been in the business, but also because the customer obsessions and innovation that we bring today, which I'm going to show to you in the next couple of minutes, and also the broad services and deep functionality that AWS offer. In the same way, I think this quote also a good reflection to yourself, to myself, for example. With many years of my IT experience coming from traditional backgrounds, it really blew my mind when I realized that what it means to have that API-driven compute, storage, and network resource available in your hands. The pay-as-you-go concepts, scaling resource on demand, using infrastructure as code, fully authenticated API with no hard-coded credential, for example, and managed service more. So I want to build today talk on this theme and discuss how we get here today and what is that next on the cloud journey. Again, these numbers in here is reflections of years of experience helping millions of customers. You see AWS provides customers with the scale for the global reach, 25 regions last time I count with 81 availability zones. Companies choose AWS because they can trust their assets and IT infrastructures to AWS who have the security processes control in place. And it's trusted by the largest corporations, including financial, banking, healthcare, government, and many, many more industries as well. AWS is uniquely customer focused. We innovate on behalf of the customers. 90% of our roadmap is based on the customer feedback. With 200 plus service offerings, we have the most complete set of services and also the feature. And then we innovate faster than anyone else. And that gap is continued to expand. If I was looking at some of the statistic in here, 2011, we released about 80 significant services and feature. And if we have to fast forward to today, on 2020, there's 2,757 services and features that we announced within that year. And with that rapid phase of innovation that we did on behalf of the customers, it brings a benefit to you as the customers, but it also brings us that economy of scale, which is help us to do more and more price reductions. And also not to forget to mention, with these fast collections of ISV and partners, each of them bring the industry expertise to help the customers. And to really cement the trust that the customer have into running their workload in AWS. There's so many services and features available. So I'm not going to spend the time to talk all about this, right? But we continue to expand our service offering to support any cloud workloads. So everything is built on this compute, storage, database, and networking as the core services, with the rich management tool and of course the security services that are available, such as encryptions, identity managements, and etc. You can leverage high-level services if you want to remove that undifferentiated heavy lifting. That things such as, for example, analytics with the data warehouse, data lake, into an enterprise applications with corporate email, virtual desktops, or perhaps a call center, into machine learning, something that I been exploring as well, text and image recognition, chatbots, natural language processing. And not only that we have a broad number of services, but these services also have a deep functionality and feature. For example, if you look at our relational database services that we offer, we have MySQL, MS SQL, Oracle, and Postgres. But not only that, this also includes a feature such as multi-AZ replications, multi-availability zone replications, automatic failover, automatic backups, encryption and rest, single sign-on, and many more. So what I'm getting with this, so with these broad services and deep functionality that we have, AWS supports the customer journey at any stage. If you see today, a lot of the organization comes from these two distinct paths, whether that is a cloud native or is that a migrations. The one that start in the cloud as a cloud native, where the later in is about moving the existing infrastructures into some sort of migration plan. One of those two typical cloud journey, there's usually typically a 4 phases. It's usually started with the project. You are developing AWS. This is maybe why you're starting and sitting here today. You may be looking at this at a project by project basis, team-based initiative. You may be looking for a new capability that you want to take advantage using a cloud native feature, maybe AI ML services, or maybe that is a data warehousing. Or perhaps you want to do some sort of like a compute and storage burst capacity by leveraging the elasticity of the clouds, or maybe for archival process. And then you build that foundations. You start to experience the benefit of the clouds, and you want to scale that. So this is where we start talking about landing zone, for example, which is building that account infrastructure, network connectivity, identity management, and many more. This is where we talk about center of excellence. What is your cloud operation model? What is that security and compliance readiness that you need to put? And then you move to the migration phase, which is to migrate existing applications, including from standard, maybe non-critical applications into mission-critical applications. And we have customers that moving the entire data center to AWS. Cloud native customers maybe not having this type of migration phase because they are born in the cloud, but they're still going through the same learning phase of scaling your adoptions into a larger part of your organizations. And then you start making that transformation to the cloud. Then you have a lot of decisions, what you want to bring, what you're going to leave, how you're going to retire that technical debt. So in this modernization phase, you start looking at maybe moving away from remaining mainframe architectures, moving to an open source, moving from commercial grade relational database, for example, into an open source database, moving from Windows to Linux, and then also about the choice of technology, whether that is container, serverless, or maybe even driven applications. And really where we're looking to have everybody in here is on this last phase. So we want that to be a reinvention phase. You come to AWS to focus on reinventions, taking advantage of the flexibilities and the capability that AWS have, and you transform your business, right? Spending more time in the market on innovation and not so much into, firefighting on the infrastructure. And looking at that cloud journey, at one point, we need to talk about DevOps. DevOps increase that organizational agility and also decrease the failure rate. There's many terminology, many discussion about DevOps. I'm not going to talk about what is DevOps itself, but you can see there, when you iterate faster, you can increase the deployment frequency, for example, from launching infrastructures in weekly and monthly into hourly and daily. I'm reflecting to myself. I used to be planning for a new data center in the Middle East. That will take at least 3 to 6 months of surveying the areas, hiring a team, sending equipments, and etc. But today, that can be done in hourly, and sometimes daily, depends on what types of tooling that you have. And chains that usually require a long time, even months, for example, now you can push that into a days, right? Through automations and a DevOps model, pipeline, and etc. And with that right process in the tool, you can also reduce the failure rate from say double digit into single digit or even zero. So this is a case study that done by Dora in 2019. So I highly encourage you to kind of take a look into that. And again, that broad and deep functionality and the benefit of AWS, it can be realized if you have a good mechanism in place, right? Putting that technology and practice together. Here's some example. For example, I mentioned earlier, deploying infrastructures. Instead of doing it manually, you can do that on demand through some sort of infrastructure as code that you can use, for example, a Terraform. And then instead of manually deploying software on ad hoc basis, you can build that into your pipelines, right? Security, for example, instead of you going to the application, to the server and manually configure that as an ad hoc, you can codify that as part of your application and services that you want to deliver. Visibility, for example, is also another thing. How do I build that visibility about things that been deployed in my infrastructure? What is running? What's the workload looks like? And then how do I instrument that, for example? Using a good tooling methods, you can build instrumentation, for example, to collect the metrics and the logs, and then using a pipelines and then infrastructure as code, you can define what is that state looks like for you. So no longer you have to trying to figure out how many servers that are deployed. You can just looking at the code, you know how many servers that you have. And then inconsistent tooling across the business, person A, team A is using a different tool. With the modern DevOps, you can start to build that standardized organizations tool and best practice and also the blueprint. And then I want to kind of end my talk today with these quotes. It's coming from Jeff Bezos. They mentioned this long time back. Good intention doesn't work. It's the mechanism that do. To give you an example, let's just take a use case of securing an S3 bucket. You can set a good intention to your team and say, okay, let's not forget to secure your S3 buckets. Let's not have a public access. And everybody agree. But very soon, you're going to see issues happen. Hopefully you are not in the news, but then you start thinking like, well, why do we have this S3 bucket open to the public? Didn't we agree we should not do that? A good mechanism would be to set a guardrails, to codify that. You provide a tool for adoptions. For example, I can build a Terraform modules for S3 buckets with all of the guardrail in place. That mechanism usually have a process, you have a tool, you have the adoption methods, and you have a way to audit and see if that mechanism can be improved and can be reviewed as well. As I said before, like managing your infrastructure using infrastructure as code is a one of great example of this type of mechanism. And then when you look at your cloud journey, you definitely have to look at how you want to manage that infrastructure and how you want to scale that. And I think Terraform Cloud in here will be a good model of solutions to help you manage that infrastructure as code. Not only it's provide this open source Terraform as the core infrastructure as code services, but it also have a deep functionality integrations with a lot of the AWS services. Now, I want to hand this over now back to Mike to talk more about what is a Terraform Cloud and how it can help you. And I hope, again, this talks that I have in here resonate well with you. Again, I hope you coming back to this with this idea of the intentions and the mechanisms. With that, I hand it over back to Mike.
Awesome. Well, thank you, Welly. I really appreciate that. What I'd like to talk about today is Terraform build versus buy. We had a good covering of AWS, and I'm just going to break this down a little bit. So my name is Michael Tharp. I'm a senior solution engineer here at HashiCorp. I've been with HashiCorp for almost 3 years now. Prior to that, I was a practitioner for over 20 years. So where I'd like to start is the Terraform core overview. Now, this may be truly a review for many people who already use it, but for some it may be new. So we'll just go ahead and cover it. So when we look at Terraform, what is Terraform, right? Well, it's an infrastructure as code solution that allows us to automate our deployments and move very, very quickly as far as I can point where I want to deploy, and then I can deploy. Now, the most common use cases that you're going to talk about and you're going to hear about is that infrastructure as code piece, right? Well, that's job one. So that's Terraform job one, is to understand that infrastructure as code is our base. Now, when we start to look beyond that, and I'll cover this in a little bit more detail a little bit later, we start to see that different use cases start to pop up, and we have to try to solve for those. So let's kind of zoom in on infrastructure as code and really understand what that is. So why is infrastructure as code important? Right? There's a lot of reasons why infrastructure as code gets touted. It's a buzzword. So when we look at infrastructure as code, really it gives us a couple of different things. One, it allows us to very clearly define what our infrastructure is in code, and then deploy that and actually realize that in real infrastructure. But when we start to use things like version control, it gives us the ability to look at revisions and look at our history to be able to share with other folks so we can get code development. So it's not just one person. And then when you look at Terraform specifically, if you look at the write that workflow, what you'll see is a plan and apply. So what we can do with Terraform, and if you're using Terraform Open Source, you're familiar with this, is a two-phased approach. We run a plan, which is a dry run, where we don't make any changes, and an apply where we actually do make those changes. So these are really important things to kind of understand when we talk about infrastructure as code. Now, specifically, when we talk about Terraform, we extend our infrastructure as code inside of Terraform with providers. And providers really give us this ability to be able to reach out into different infrastructure providers and be able to do things like provisioning. So when we talk specifically about AWS, there's a lot of services and features that get deployed into AWS. And so for us to do that, we have to use a provider in order to be able to securely connect. And part of that is our deep integration with AWS services. So we're trying to work as closely as we can, not to do like a least common denominator type of provisioning, but really to do that full featured capabilities. And that really comes from the code development effort that we have on the AWS provider. So what does that mean? Well, that means that we have a team at HashiCorp, right? Somebody at HashiCorp and somebody at AWS are working on this provider to really kind of push it forward and to keep it consistent with the services and features and functionality that we all expect. So we talked a little bit about AWS adoption. I want to talk a little bit about Terraform adoption. And you're going to see they're kind of hand in hand, right? So what Welly talked about and what I'm going to talk about are very similar. And really what the hinge point is organizational complexity. But what you're going to see is kind of three different categories here. You're going to see free, teams and governance, and business. And let me explain what those are. So when we talk about free, that's really the basic building, right? This is where a lot of folks start. And this is really designed for the individual. So when we look at Terraform Open Source, it's designed for the individual. It's designed for one person to be able to go on their laptop and learn. And that's a great way to learn. But when we start to scale, we start to see some challenges with that, right? So we want to include other folks, right? We don't want to just have one person on one machine. We start to look at things like compliance and management, and then ultimately self-service. So it comes down to organizational complexity and really kind of where we're at in our journey as far as Terraform adoption. So let's talk about open source. So what you're going to hear, and if you've ever been to any HashiCorp talks in the past, you'll hear us talk about workflow, right? Workflow, not technology, because workflows are so very important to consistencies, to security, to really allowing us to scale and automate the way we would like to. So when we look at the Terraform open source workflow, what we see back to that individual idea, right? A single machine, we go and we download the Terraform binary, and this is a Go binary, runs pretty much on any operating system out there. And then we're gonna write some configs, right? This is where we're gonna define our infrastructure, write something really cool, get some cool infrastructure out there. Then we're gonna run a Terraform init. And what this is going to do is from our machine, it's going to reach out to registry.terraform.io and say we're going to deploy some AWS infrastructure. That provider will then be pulled down so that we can use it locally, along with any other providers that we have. Next, we'll run a Terraform plan. I talked about this earlier, this two-phase approach. This is truly a dry run. We're not making any changes here. But what we're going to get is we're going to get an output of everything that's going to change. So if you've already run Terraform and you've got a state, it's going to tell you what's changed, if anything's changed. If this is all brand new, you're going to see a lot of changes, obviously, because everything's brand new. And then ultimately, we're going to run our apply. This is where we're actually going to build infrastructure, right? Your machine is going to reach out directly to the cloud from your machine, and it's going to say, all right, I want you to build these things based on the code that I have. Once that's complete, we're going to write everything to a state file. Terraform is completely stateful. What that means is we're going to manage all of these resources for you in the state that they're supposed to be in, so that way, if something changes, we can put it back the way it was. So there's some considerations when we start talking about open source that I think we all need to be aware of to kind of make sure we're all on the same page. First and foremost is access keys. So anybody who's ever worked with infrastructure knows that usernames, passwords, access keys, security keys, API keys, these are all things that we have to manage and deal with. And we have to find a way to secure them. Well, Terraform is no different, right? It has to have permissions in order to be able to do the work that it needs to do. So a lot of times what we'll see is environment variables or maybe static configs. It should never be in your source code, first and foremost. Don't ever put that out in the source code. That's a bad idea. So when we're looking at this, we have environment variables and we've got static configs, but we still have to deal with those access keys. We've got a state file, right? So the state file kind of keeps track of everything that we have and everything that we're going to manage with Terraform, and it's going to have sensitive data. There's no way around it. Absolutely going to have sensitive data. So we need to protect the access keys, obviously. We need to be able to protect the state files. And the one thing about open source is it doesn't really understand collaboration, right? Because it's designed for an individual. So it's a single file running on a machine. And then obviously no API. With OSS, we're looking at it and we say, you know what, I really want to be able to automate. APIs are the gold standard for automation. We don't have that available to us. So what we end up with is some workarounds. Now these are common, you see these a lot, where we're trying to make open source work in an environment that really it's not going to work very well. And most commonly what we see is dedicated VMs or containers. Right, so we're gonna dedicate a machine, we're gonna go download and install and configure everything on that machine, and then try to run everything through that, or container, right? And a lot of times you'll see these in CI/CD type workflows where we're trying to manage runners and maybe we're bringing them up dynamically in a container, and then we have to account for different Terraform versions or different versions of our code, or maybe some leftover code. So these can be very, very difficult when we're trying to manage them. And we still have the access key problem, right? We still have access keys that we have to protect. We're just shifting them somewhere else, right? But they're still in that open mode. And then as we start to scale as well, we also have to deal with things like state. So from a state perspective, our state files are going to have that sensitive data that we know, right? And we have to be able to control access to them, but yet we have to give people access to them, right? So it kind of becomes this sticky type of scenario, as well as when we start to scale, there's going to be more and more state files that we have to deal with. So what does this look like at scale? Well, Terraform open source just doesn't scale. And for all the reasons that I mentioned before, but let's kind of break these down and kind of look at these and see what that looks like, right? So whether you're talking about Team X, Team Y, or Team Z, what you're seeing is something that happens very consistently with open source. And that is every team picks up open source and creates their own thing, their own Frankenstein. They put all their own scaffolding around it, right? They kind of try to glue everything and duct tape everything together to make it work. So maybe Team X, they're using a single server, maybe a single laptop. And that's great until that laptop dies and we don't have backup of our state, and or maybe that person goes on vacation, takes that laptop with them. Right, Team Y, well, they decide to use server access, but we still have to give everybody access to that server. We haven't really done anything, we just shifted it away from a laptop. And then finally, Team Z, they're using CI/CD tooling. Again, just shifting the problem. We still have the same issues. We still have to secure the same resources. We're just doing it inside of a CI/CD pipeline. So the one thing that we see with all of these is inconsistency in our workflow. And these create a lot of problems. It's very hard to be confident with my deployment if I have inconsistent workflows across the board, as well as security and compliance. This is very, very common. So security and compliance teams do not like decentralized workflows because you don't have visibility. There's a lot of things you don't have, but ultimately that confidence of being able to say, I can deploy on-prem or I can deploy into AWS the way I want to, the way I need to, I have to have some visibility. I have to have some centralized control, and I just don't have that with open source. So let's talk about Terraform Cloud. So first and foremost, Terraform Cloud is built on Terraform Open Source. So the core of Terraform, which is Terraform Open Source, that's what we build Terraform Cloud on top of. But what we do is we add the features and functionality to speak to the specific things that we just talked about. I'm going to break each of those down, but from a high level, here's what you need to know. Terraform Cloud is fully managed. It is a SaaS service. So you don't have to manage or control anything. From a compliance and management perspective, we've got you covered there, right? Getting that consistent workflow. And then self-service. Once we start to build out, we can build really fast and we can move very agile and secure. Well, now we want to actually enable other folks to be able to deploy their own infrastructure. So we don't have just one team trying to do everything. And really what this boils down to is enterprise features, right? Across the board enterprise features that we need in order to be able to scale to what organizations require. So let's see what that looks like from an infrastructure as code perspective. So we talked a little bit about workflow, right? We saw kind of the disparate workflows that we had. With Terraform Cloud, we introduced a consistent workflow. And this consistent workflow really is the key to getting us comfortable with being able to deploy very quickly with those guardrails that we need as an enterprise, and ultimately being able to allow everyone to deploy what they need for the organization, because ultimately we need to get our apps live, right? Whether they're internal apps or customer-facing apps, we need to be able to get those live, and that consistent workflow is going to help us there. So I talked a little bit about state before. I'm going to kind of drill down into that a little bit. So infrastructure state, we know it has sensitive information in it. Absolutely, there's no way around it. So when we look at infrastructure state, what can Terraform do, Terraform Cloud specifically, do to help you with that? Well, first and foremost, we're going to encrypt your state. That's awesome because we don't have to worry about the idea of somebody coming across the network and breaching, but we're also going to provide RBAC controls. Now, this is huge. So because our state file has sensitive information in it, we're going to want to control who has access to view, who has access to read, who has access to write that state file. And this is really kind of controlling the operations of what people can do inside of Terraform, but it really gives us that control and that visibility that we need from a security perspective. Now, we talked a lot about infrastructure as code before. We're going to talk about it again. We talked about version control. Version control is pivotal, right? When we start writing infrastructure as code, we're going to have to store it somewhere. And almost always it's going to be in a GitHub or GitLab, some sort of version control system. Now, the reason why that's important, we kind of covered that before with the history and all of those things. But when we look at open source, it's really disconnected, right? So I basically have code and I have it in a VCS, and then I have maybe Terraform running somewhere else, but I don't have that marriage of VCS and Terraform. Well, with Terraform Cloud, we actually answer that with a solution of a direct VCS connection. This is actually a two-way connection. It's actually really cool. So from the Terraform perspective, we're actually able to reach into, say, GitHub, and we're actually able to watch for code changes, right? So the reason why this is important is I no longer have to try to manually orchestrate via external orchestration engines or multiple tools. I can actually orchestrate directly from Terraform. So this is really handy when you're saying, hey, you know what, I'm gonna create a pull request. That pull request then gets merged. That merge then causes the infrastructure to be changed or built, right? You can go from 0 to 100% automation, and there's a bunch of steps in between where you can do approval workflows, but just understand that that's very, very powerful. As well as when we talk about the VCS side, Terraform also has the ability to do what's called speculative plans. These plans are really, really important because most of the time when we're gonna take and do something maybe like a branching strategy with that pull request, we're gonna run some automated tests. We can include Terraform in that, and Terraform will actually run a plan and make sure that our code passes syntax testing that's actually going to work, right? That it passes all of our policies, and then report back so that way we don't merge something that is gonna break ultimately when we try to deploy it. Secure variable storage. Talked about those access keys, those API keys. It's important to understand that variables in Terraform, if you're writing Terraform today, you know how important they are. Really, they give us the ability to really make things modular. In doing that, we have sensitive information we're gonna have to protect. With Terraform Cloud, we actually can handle that for you with secure variable storage. Really what this comes down to is you have the ability inside of Terraform Cloud to define a variable and define a value, mark it as sensitive. And once it's marked as sensitive, no one can ever see it again. Terraform's the only one who knows about it. You can overwrite it, but you can't see it. And the value this gives you is the ability to be able to hand off a workspace or hand off a key without having to give somebody full access to the key. They just have access to use it inside of Terraform, right? So we don't have to worry about those leaks and those security concerns of access keys. And then workspaces. So many times when we look at infrastructure, we see it as kind of this this kind of monolithic thing. When we manage our infrastructure, we have a lot of tools, but we manage our infrastructure. With workspaces, if you're using open source, this construct is here. Most people don't use it because it really just ends up being a folder in another state file. But in Terraform Cloud, it becomes really a pivot point. It does a couple of things. First and foremost, it allows us to manage our infrastructure in a more logical way. So instead of looking at it as a large monolith, let's start breaking it down. Maybe we break it down on teams. Maybe we break it down based on applications. But ultimately, we're able to break that up. The advantages are pretty clear on that. One, blast radius. We don't have to worry about changes in one area affecting another. Also, we get RBAC controls. So we can control which teams can do what, which teams can see what, and who can interact with who. So we're really kind of taking control of how we want our infrastructure to look, how we want it to run, and really those domains of management. So compliance and governance is the next part that I'd like to talk about. And kind of going back to this consistent workflow, we see the same thing again with compliance and governance. So when we look at this, and if you look at that diagram on the right, what you're going to see is you're going to see something that looks a little bit different when we start talking about this consistent workflow. And that's in between that plan and apply, that two-phased approach, you're going to see that something's inserted in there. And this is where we actually insert policy. The ability to do governance and policy in between the plan and apply. Why is that important? Well, if I'm doing a plan and apply, where plan doesn't actually make a change and apply does, and I do policy check in between those, that means that if it doesn't pass the policy check, it never goes out. So it doesn't mean that I have infrastructure out there running for 5 minutes, for 1 minute, for 1 second that's misconfigured. It's always correctly configured and meets our constraints. Which brings us to Sentinel. We call this Sentinel. Just like we have infrastructure as code, policy as code. Easiest way for me to explain this is, as an infrastructure engineer, many times I would work with the security and compliance team, and what I would see is they would say, hey, you know what? We need you to make all your servers look like this. And they'd hand me a Word document or email me a Word document or a spreadsheet and say, make all your stuff look like this. Well, that's great. And I can do that if I'm doing like 1 or 2 resources. But what about 1,000? What about 10,000? What about 100,000? That becomes untenable very quickly. Well, what if I could take those non-actionable items by themselves, right? Those documents don't do anything on their own. But what if I could turn them into something actionable? And that's exactly what Sentinel does. It allows us to really take that policy as code framework, take those policies that we had in those spreadsheets and actually apply them so that we never have misconfigured infrastructure going out the door. Including that as cost estimation. So I know Willie talked a bit about cost. We're always going to make sure we're conscious of our costs. Terraform Cloud built in has cost estimation. So what does that mean? Well, I know exactly how much everything's going to cost when I deploy it, and actually can create policies around that. So that's very powerful, right? I could say, hey, you know what? Development shouldn't cost more than $100, or no, you can't use these huge GPU instances in development, but we can in production. So you can start specifying those very specifics, but giving yourself the consistency you need and the control you need on cost. Now, we talked about a little bit about that. It's also important to understand that nobody has any interest in having another username and password. I haven't heard anybody who said, you know what, I really like just another username and password for a site. So to answer for that, we have SSO, single sign-on, just like you would expect. Whatever your authentication provider you have, if it's SAML-based, we can actually integrate that in. So whatever process you had with this authentication, authorization, two-factor, well, we'll just work its way into Terraform via SAML. Once we got everybody in, this is where we start to get the slicing, dicing of RBAC. So we can really start to say, let's take these teams, let's break them apart, and let's decide who can do what. Right, so this is really kind of the key area. I can start saying, hey, these teams can only see these workspaces. They can only do these things inside of those workspaces, right? So we really get a lot of flexibility and control while we can still get full visibility. And the whole time, we're logging each individual thing that happens inside of Terraform Cloud. So there's never an action or an item that doesn't get logged. And the reason for that is everything's API driven, so we just log the API. So you can take this and drop this into a SIM. We actually have direct Splunk integration if you've got Splunk. So just understand that everything that we're doing is very clear and concise and logged. Then self-service infrastructure. So we're able to build really fast now, and we're able to secure everything. And we have those guardrails already built in. So why not enable the other teams to be able to do this? Why not enable teams to be able to help themselves? Well, that's exactly what self-service infrastructure does, right? We've got the compliance guidelines, we've got the guardrails. Let's go ahead and allow them to do that. And we do that via modules. So if you're using modules today, very common, really it's just reusable code. from its very basic form. It's just going to be some sort of reusable code, so I don't have to reinvent the wheel every time. But if we kind of expand upon that and start looking into Terraform Cloud, what we see is the ability to enable what's called the producer-consumer workflow. Now, this is really, really important as we start to scale, because it's going to be more difficult to try to maintain a small team of Terraform folks that do everything, as opposed to saying, hey, why does the Terraform team create the code that we need, and then allow people who maybe they're familiar with Terraform, but maybe just mildly. They're not necessarily Terraform folks, but they know a little bit about it, or maybe they don't know anything at all. And you say, you know what, let's go ahead and enable them to be able to onboard their infrastructure in a way that's meaningful to them, ultimately empowering those teams while still maintaining the control that we would expect, right? And that's really what that producer-consumer workflow looks like. So we're creating modules. I talked a little bit about the registry. This is where the providers are held as far as the public module registry. So that's registry.terraform.io. We also have modules out there that you can consume that are created by the community. So if you want to get started today, go ahead, jump out there, check out AWS, look at all the modules that they have, right? You want to create an EC2, S3, VPC, there's many things out there. Now, well, that's great for an individual, right? And it's great to get started. Most likely, whatever that community template is, probably isn't going to work for our organization overall, right? At least not universally. So we have to be able to change and kind of modify each of these individual modules to be able to meet our needs. So we do that with the modules, and then we host them with the private module registry inside Terraform Cloud. So what this is just like the external registry, an internal registry only available to your organization, where you can then host and provide revisions of those modules and version through. So the way we access them, if you're using modules today, you're probably used to using things like Git references and tags. You don't have to do that. Now we have a very sane way of saying, you know what? Here's the module I want to use. It's in the private module registry. Here's the version I want to use. So rolling forward, rolling back, and really consuming those private modules are much easier than before. And then finally, remote operations. So giving people direct access to the cloud from their machines is usually something that we do, maybe we don't want to do, but ultimately for deploying, we don't have to do it. With Terraform, we actually offload all of that responsibility onto Terraform Cloud. And we do that via remote runners. So when we run in Terraform Cloud and we have a workspace and we say, go ahead and run my plan and run my apply, what happens is we spin up a runner, and that runner is purpose-built for that specific run and only that run. And then everything gets tossed when it's done. So the advantage here is Terraform is aware of different Terraform versions. And this is a huge hurdle that you run into if you're not using something like Terraform Cloud is, okay, so I got some people using 13, some people using 14, right? Maybe some people are using older. It becomes very difficult to manage those versions and all the different containers and runners. We manage all that for you. It makes it very easy, as well as direct connectivity to the cloud is no longer required. We still may want to allow folks direct connectivity to the cloud, but we don't have to, not to provision. We can actually offload that to Terraform and really kind of control our workspace and really kind of control our connectivity. So hopefully that was able to kind of resonate with everyone. And I want to talk a little bit about adoption again, because this does look very similar to what we talked about before, but let's talk about that in the aspect of Terraform Cloud. So from a Terraform Cloud journey perspective, it's kind of the same thing. We're going to start with build. Now with Terraform Cloud, even in free, you get some basic capabilities that you didn't have in open source, right? And mainly that's the collaborative infrastructure as code. So being able to collaborate via sharing state files, or basically putting state files available out so that other folks can use it. But as we start to build large organizations and that organizational complexity starts to change, it's the same thing. But with each one of these, we actually give you the ability to be able to upgrade to be able to meet your needs, right? So as we start to move from left to right, if you move all the way to the right, what you see is Terraform Cloud for Business. And this has all the features that we just talked about, where we talk about being able to do infrastructure as code like we were doing before, but be collaborative about it. We're going to do teams and governance, right? We're going to have all those policy engines, all the goodness that comes with those, right? All the advanced security and auditing, as well as support for self-service infrastructure, things like ServiceNow and other things. So Really handy, really good to know. So if everything I talked about here is of interest to you, and you really want to get your hands on it, because for me, that's how I learn, right? I was like, this is all cool, and I want to learn more, but I want to see it in action. We can actually help you get started today. So really what this looks like is we can provide you with a test drive of the Terraform Cloud for Business. And really, one thing that's important to note is, as you're going through this trial, Terraform Cloud for Business is available on the AWS Marketplace. So you can transact over the Marketplace, which is huge. But we're going to give you 60 days free to be able to work with that. And basically to claim that, you'll just contact aws-marketplace@hashicorp.com. Like I said, you guys will have a copy of this when we're done. And then once you get your hands on it, right, we've talked about a lot of things and there's a lot of different features and functionality, but if you want to walk through, we actually, me and Welly actually created a hands-on self-paced workshop hosted by AWS that works specifically inside of your AWS environment with Terraform Cloud, so that you can kind of get started and get more familiar with these features and see them actually in action. So I hope that I answered some questions, maybe about open source and how we're going to scale, covering Terraform Cloud for Business. And I'm going to go ahead and turn it back over to Greg and let him take it from there.
Awesome. Well, thank you, Mike, and also thank you, Welly. Really appreciate the content that you provided, and I hope everybody in the audience has really learned a deeper level about both Terraform and AWS. Please note within the chat there is a link to the survey. By filling out that survey,